In this video, I would like to talk more about the multiple inheritance with the super. Today's session might be a bit heavy for you. As I said, many people prefer to avoid talking about these details because they are going to be confusing, but they are very informative. So please do not feel bad if you didn't get what I'm saying from the first time or even the second time. Feel free to skip and come back later, but still something that's very useful and educative for you to learn about it. Previously, I said to you that super function is going to return for you an object of the parent superclass. This was an oversimplified statement. It actually has two mistakes. The first mistake, which is minor, it actually doesn't return an object from your classes or your superclass. It actually returns a proxy object. For simplification, remember we learned it before a wrapper class in one of the assignments. The proxy object has inside it your actual object, so just helping to it's going to do more complicated things behind the scene. That's why we do not use actually your parent class, and we'll learn now why. It actually returns another type of objects that is going to handle the calls by itself. If you try to print the type of the super function, it's going to say class super. That's why I'm saying it isn't actually your object A here, for example. It's going to be another class super that behind the scene is going to call your class A. And by the way, super itself is an abbreviation to super, the class name, and self. This is important to know because in some scenarios you cannot go with the implicit call here and go with the explicit scenario. Now, what is really tricky and what's really critical is that super doesn't necessarily call your parent, and this is sometimes make guys a bit complicated. So the moral of that is super is actually much more complicated than you think about. Oh, super is going to bring my parent. No, it isn't like that. Let's go in the details. I would like you to read this code here, which is actually represented with this simple tree, and tell me what is the output of this program. Take a couple of minutes of your time. Let's go in details. You probably guessed something like DBA, maybe. This is good trial, but still wrong. The correct order is D, B, A, and C. Why? Here is the moral of today's lesson. The super function actually is using the MRO to find the next method to call in the hierarchy. So the super doesn't necessarily call your parent. It's actually calling your next MRO object, which is why it causes confusion in practice for some guys. Let's go in details here. We are here at D, printing init D, and then we have a call to super. Now, what is the MRO of D? It is D, B, A, C. So the super is going to ask the MRO, what is next after D? It is B. So the MRO of D is going to call B. Now we move to the B. The B is going to print init B and call super. What is the next after B in the MRO? It is A. So B is going to call A. What is next after super A? It is C. Wait a second. This is very confusing. After you call init A, super is going to call the class C. Wait. A doesn't have a parent. Super should actually refer to the object class, the super object class. But in practice, super will call class C. A doesn't have C as a parent, but it's going to call it. Why? Because super is asking in the hierarchy of D, what is next after A? It is C. And observe that this also means that super this time is calling C. If someone has another hierarchy, super of A is going to call another object. So the behavior of super here is based on the runtime. It is based who is inheriting from what. It is mainly and specifically based on the MRO. So never forget that. Super isn't going to call your parent. Super is going to call the next class based on the MRO of the self object, which is here the initially coming from D. And also we stressed that before, that all of these objects here, the self, in this call are going to refer to an object of type D, which has the MRO, D, B, A, and C. So again, never forget that. So the remaining of today is more of administration for this idea. Let's try to comment line number 5, which has a super for A. So someone during development might tell himself that class A has no parent. So I'm going to skip this super code because it is useless. I don't have a parent anyway. But you are going to be shocked that class C isn't initialized. And this is one of the common mistakes in industry. Sometimes your inheritance hierarchy in multiple cases will have missing classes from initialization. So if you did this mistake here in line number 5 without a super call, class C will not be initialized, and this is going to fail in runtime. So that's why understanding super in multiple inheritance hierarchy is very critical. Let's try to get the details of this class. Take a couple of minutes. Let's trace together. In the first time, we are calling an object C of value 20. So we come here, a val would be 20, and then we will print init C, and then we are calling A and B. A is expecting from us a parameter, which is initialized to none. A is going to call init of A and 20. So we now jump to A with value 20. So we'll print init A20, and we will call super of init here. Now, what is there after A in the hierarchy of C? Nothing. We have only the object class because the hierarchy of C is CBA object. Okay, so now we go back to here and then we call the B init. B init is going to print init B, but it's going to call super. Although B doesn't have a parent, but in the order of C here, C is CBA object, B should have A after it in the MRO. That's why C is going to call init A again. But this time we don't have a parameter, so A val is going to be none. So we'll print init A again. So the overall of the output is init C, init A20, init B, init A none. Init A none here is very counterintuitive and wasn't expected. Let's try to remove the none from here. What's going to happen? You will get an error. The error would say that missing one parameter at line 12. And someone who doesn't understand the super will get shocked. Super is calling the parent of B, which is object. Why do we need a parameter here? He will never understand what is happening. B is actually calling A, and the code itself is wrong because A is going to be initialized twice due to my call here for A and B twice. So that's why you better call only super, and if you have to call more than a class this way, this might cause a lot of problems with a mix of super and explicit calls this way. So be careful about that, and be careful about the mixing of the explicit way and the implicit way, and what does it might do. Before finishing, I would like to tell you about a very popular problem named as the diamond problem. In the diamond problem, we have 4 classes at least is doing the following shape. We have a class who is inheriting from 2 classes, and then these 2 classes are inheriting directly or indirectly from another common class. So it looks like it is doing a diamond this way. This problem has 2 issues. One of them from language perspective, and one from the other one is development perspective. In language perspective, it will depend on the language and how it is going to handle the diamond problem. In something like C++, it's might be problematic. In Python, this isn't going to cause a problem because we have the MRO. So the MRO is going to say copier first, scanner, I think power device first. No, printer first, then power device. Remember, child is always before parent. Now, the problem is, from development perspective, this is going to cause more and more confusions, and you should avoid using this style. As you see, already multiple inheritance is very problematic. If you are adding for it also the diamond problem, you are making your life and your team life hell. That's all.